explanation now. I'd like to go through a specific instruction, but I don't think we actually have time if we want to keep the video under 3 minutes. But so at a high level, we have the inputs to this module as the rows in this matrix, so these wireline inputs. And the columns are the outputs of this module, and they're called the bit lines. So by default, if none of these lines have a 1 on them, let's say all the wire lines are 0. This doesn't actually happen in practice, but let's say they're all 0. These columns will all be pulled to VDD through these resistors. So basically you'll read 1s on every single bit line wire. On the other hand, the decoder that we actually feed into the ROM instruction triggers one of these high at a time, corresponding to the instruction that we want to read. So wireline 0 would be high for instruction 0, 1 would be high for instruction 1, etc. And that's all taken care of by the decoder. But what happens is there's actually NMOSs in specific locations on these columns, and when these wire lines go high, the transistors connected to those wire lines will actually be shorted as the VGS becomes greater than the VT of the transistors, shorting these columns to ground. And so by default we have all 1s on these bit lines, but as soon as we trigger one of these lines, corresponding columns will be shorted to ground through the transistors that we trigger, and they correspond to the 0s on the output. So like we can see here, we should have transistors on columns 2, 3, 8, and 9 for instruction 0. So we go to wireline 0, and indeed we see transistors on the corresponding columns. So that's how that works at a high level. Quick look at the decoder that's used to feed the wireline inputs to the instruction memory. So these basically take as inputs the PC outputs and basically trigger the corresponding wire lines that we want. So I basically used a truth table again, with the inputs being the PC bits and the outputs being the wireline bits. Did truth table, K-maps, reduced logic, and basically got logic for each of the corresponding wireline bits. So these ensure that only one wire is set high at a time for the instruction memory, corresponding to one instruction at a time.